Welcome to the DIY Honda Garage channel. The DTC P16F6 refers to an issue with the starter cut relay 2 control circuit high voltage in the Honda Accord models from 2017 to 2023. This diagnostic trouble code indicates that the circuit meant to control the starter cut relay is experiencing high voltage, which can lead to starting problems. This issue is often related to the relay circuit board, a key component that controls the electrical flow to the starter, ensuring that the engine starts only when appropriate. The relay circuit board is typically located near the engine compartment, and the connection to the powertrain control module, PCM, is crucial for the proper management of starter operations. If this code appears, it is essential to follow a systematic troubleshooting approach to identify and resolve the underlying cause of the high voltage in the circuit. The starter cut relay 2 is designed to control the electrical current that enables the engine to start. In essence, it acts as a switch that is managed by signals from the PCM, which monitors various engine parameters. When high voltage is detected in this circuit, it can impair the relay's functioning, leading to potential starting difficulties. The relay circuit board, where the starter cut relay 2 is located, can be found in the engine compartment and is often integrated into the fuse box or close to it. Understanding the circuitry and the connections between the relay and the PCM is key for diagnosing this fault. When troubleshooting, it's important to carefully check these components as they play critical roles in the vehicle's starting system. There are several potential causes for the DTC P16F6 to trigger. One primary reason could be high voltage detected in the starter cut relay 2 control circuit, which may occur due to electrical faults such as short circuits. Another common cause is a malfunctioning relay circuit board that could be faulty, rendering it unable to manage the electrical flow adequately. Additionally, a short to power in the wires connecting the relay to the PCM could disrupt normal operations, causing high voltage levels. Therefore, understanding these causes helps in isolating the issues and implementing corrective measures to restore functionality. The goal is to ensure that each component functions as designed to avoid starting complications. When DTC P16F6 is triggered, several symptoms may manifest in the Honda Accord. The most apparent symptom is the engine refusal to start, indicating that the starter cut relay 2 is not engaging properly. Additionally, the vehicle's onboard diagnostic system will likely display the specific error code associated with this issue, leading drivers or technicians to further investigate. Other observable symptoms may include strange noises or clicks from the starter relay, which can signify mechanical failure. It's important to take these signs seriously and refer to code readings for a comprehensive diagnosis. Being aware of these symptoms is crucial for timely intervention, ensuring that the vehicle maintains reliable starter performance. To begin troubleshooting DTC P16F6, the initial step involves verifying the problem through a systematic approach. Start by turning the vehicle ignition to the on mode without starting the engine. This allows for the inspection and management of electronic components. Using the HDS, which stands for Honda Diagnostic System, clear any stored DTCs to reset the system. After clearing the codes, proceed to start the engine and observe if the DTC reappears. If the P16F6 code becomes reactivated, this indicates that the issue is confirmed. You must continue with the diagnostics. Conversely, if the code does not present itself again, it could suggest an intermittent fault where the system is currently functioning without issue. In this next troubleshooting step, the focus shifts to the relay circuit board. Begin by turning the vehicle's ignition to the off or lock mode, ensuring that there is no electrical power flowing through the system. You will then need to physically remove the relay circuit board for inspection. Once removed, test the relay circuit board for functionality using an appropriate testing tool. It is essential to verify that the board operates correctly. If it shows signs of failure, it will need to be replaced to resolve the issue indicated by the DTC P16F6. Confirming that this board is in working condition is crucial, as it plays a pivotal role in controlling the starter circuit. The third troubleshooting step involves a more in-depth analysis of the circuit. Start by jumping the SCS line, which stands for Service Check Connector, utilizing the HDS. This procedure prepares the system for comprehensive diagnostics. After connecting, disconnect the PCM connector A, which contains 50 pins, to isolate the circuit you want to evaluate. Next, turn the vehicle ignition to the on mode to initiate power to the circuit. You need to measure the voltage between designated test points, specifically between PCM connector A, pin number 23, and a solid body ground. If the voltage reading is 0.1 volts or lower, the ST-cut RLY2CL wire is functioning as intended. If these criteria are not met, further investigation into wiring integrity is warranted. Once all identified repairs have been performed, it's imperative to conduct a final verification to ensure everything is functioning correctly. Start by reviewing all repairs made to the starter cut relay and its associated circuits. After validating these repairs, use the HDS to check for any remaining DTCs in the system. This process will help confirm that the P16F6 code has been resolved and is no longer active. Additionally, restarting the vehicle should demonstrate that the engine starts without complications. This final verification step guarantees that no additional issues persist, and that the starting system's operations are restored to normal. Confirming the vehicle operates as designed not only completes the repair, but also ensures the vehicle's reliability. Preventive maintenance is essential in addressing issues such as DTC P16F6 proactively. Regular inspections of electrical components, especially those related to the starter system, can prevent faults from escalating into more significant issues. It is also crucial to maintain cleanliness of electrical connectors to ensure they do not corrode or gather dirt that may impede functionality. Keeping wiring intact and free from wear or damage can prolong the life of your components and reduce the likelihood of future malfunction. Integrating these aspects into routine maintenance can help mitigate risks associated with high voltage in starter circuits. Ultimately, a systematic approach to preventive care can enhance vehicle reliability and performance. In summary, addressing DTC P16F6 in the Honda Accord models from 2017 to 2023 requires a systematic troubleshooting approach to diagnose and rectify issues effectively. It involves verifying the DTC, checking the relay circuit board, and conducting thorough electrical measurements to understand the cause of high voltage in the starter cut relay 2 control circuit. Subsequent verification of repairs ensures that the vehicle is fully operational and free from recurring issues. Moreover, implementing a regular maintenance schedule enhances the vehicle's longevity and performance. Taking preventive measures will not only help in avoiding future difficulties, but also improve the overall reliability of the vehicle's starting system. Please like and subscribe to the channel. See you next time.